Have you ever wondered how to fly? Why birds can do it so easily and humans, try as we might, just can't? I'm sure everyone has had that dream, where they are flying high over the city, free from any inconvenient laws of physics. However, in the real world, the reality of gravity is always there to bring you crashing back down. Every object on Earth has a force pulling it down, due to its mass and gravity. This force is not that strong. Every time you jump, you are overcoming it, but it's always acting, which is why you always land a few seconds later. To be able to fly, all you need is a force in the upwards direction that can balance the downwards force due to gravity. If you have balanced forces, the net force on your body is zero, so you won't be being pulled upwards or downwards. You will be hovering. To be able to fly, we need to find a way to produce this upwards force. There are two ways we've figured out how to do this so far. The first involves a jetpack, or something similar. A jetpack works by forcing air downwards really fast. I don't want to make it too complicated, but Newton's third law states that every action has an equal and opposite reaction. So if the jetpack is forcing air downwards, it must also be forcing itself upwards. Now if we strap ourselves onto the jetpack, provided the upwards force is big enough, we can use it to balance our downwards force, and away we go. This all seems very easy, but there are a few issues associated with this. The main problem is balancing the forces so the person doesn't spin wildly out of control. There have been some solutions to this problem, but none that really make jetpacks a practical way of flying, yet. The second way to fly is by using wings. The key to flying with wings is in the shape. Birds and planes have a very specific shaped wing, like this. When a wing of this shape is travelling through the air, it splits the flow of air around itself. Due to the curve on the top side, the air going above the wing has to travel further than the air going below the wing. This means it must be moving faster and, according to the Bernoulli equation, have a lower pressure than the air on the bottom side of the wing, which will have a high pressure. The high pressure creates a force on the bottom of the wing as it always tries to move towards the low pressure. You can see this effect with a balloon. The air on the inside of the balloon is high pressure, and as soon as you release the top, it wants to come out into the low pressure air surrounding it. Now if you put a wing or a piece of paper over the top between the pressure difference, you can see that the high pressure air is forcing it upwards. So provided our actual wing keeps moving through the air at speed, the high pressure force on the wing will hold it up. This pressure force is also combined with an angle on the wing, which deflects air downwards, giving a similar result to the jetpack scenario. So there's your upwards force. Easy! So how do you think humans can use these theories to fly? Do you think we should keep working on the jetpack problem, or should we be working on developing people-sized wings? Let me know your thoughts in the comments below. Thanks for watching, and keep wondering.